A party balloon is being filled with helium. As the balloon is filling, the radius of the balloon is changing at the rate of 3 inches per second. Write a function that represents the radius of the balloon, r of t, after t seconds. So anytime you have a word problem, a story problem, application, real world problem, you want to make sure that you're always keeping track of your variables. And sometimes the variables are defined for you, like in this case here, and sometimes you get to define the variables yourself. But regardless, you want to keep track of what you've been given and what the variables represent. So in this case, t is going to be the number of seconds. So time, but I like to write time in seconds or number of seconds. And we're being asked to write a function r of t. So r is going to be the radius of this balloon. And since the radius, it says, is changing at a rate of 3 inches per second, that's a rate of inches per second, that tells us then that the radius is measured in inches. So we are trying to take the information in the problem and translate it into a mathematical equation. This is translating. It's very much like learning a foreign language. We're translating from words to math. And if you struggle with that, I always recommend that you get organized, and a good way to get organized is by making a table. So we have time, and then we have the radius of the balloon at any given time. So if the time was 0, the radius is 0. After 1 second, because the balloon, it says the radius is changing at a rate of 3 inches per second, that means we will have gained 3 inches in 1 second. And then after another second, we'll gain another 3 inches. So 3 plus 3 would be 6. And after another second, we'll gain another 3 inches. So that would be 9. And sometimes seeing the numbers this way can help you see the relationship that we're gaining 3, essentially 3 inches in the radius value for every 1 second that we're gaining over here. And this means we have a linear relationship. We have this constant rate of change. So my function, my equation, which is going to be r of t, we can find the radius by basically multiplying the time by 3. So that would be 3 times t. Something else I want you to pay attention to, when they use the word function specifically, that means I really do want you to use function notation. In other words, I don't want you to leave your answer as just r is equal to 3t. It'd be better to write r of t the way I've done here. R of t is equal to 3t. Part B wants us to write a function. Again, pay attention, the word function, that expresses the volume this time, and the volume will be v as a function of the radius r. Now, I don't expect that you remember the volume formulas from geometry. You might have to Google that. High school geometry may have been a really long time ago. But in this case, we are going to make an assumption, and we're going to say that this balloon is close to a sphere as it increases in volume. So we'll use the volume formula for a sphere as a way to model the volume of this balloon. Even though a balloon is not going to be a perfect sphere, this will be a close mathematical model. So if you Google the equation for the volume of a sphere, you will find that it is 4/3 pi r cubed, where r is the radius. So now let's go ahead and utilize our function notation. This is the volume as a function of the radius. So that would be 4/3 pi r cubed. In other words, if I put in a radius value, I will get out the volume of that balloon. Part C is asking us to evaluate V of R of T. So let me say that one more time. Remember that open dot is composition. That implies we're going to be finding a composition. And we read this V of R of T. And we could also rewrite it like this, V of R of T, where we use the parentheses. I like this notation a lot because I think it's very clear. We can see visually here that R of T is on the inside. In other words, we're plugging the R function into the V function. So looking up here, if we know the radius as a function of time, then that radius function is going to be substituted in here in for R. That's a composition. So we're going to have 4/3 pi times the radius cubed. But again, we're subbing in our radius function, which was r is equal to 3t. So if we simplify here, remember 3t, if we're cubing 3t, we're multiplying it by itself 3 times. So we'll have 4/3 pi. 3 times 3 times 3 is 27. And then t times t times t is t cubed. Let's keep simplifying. This is really 27 divided by 1. So we know that 3 divides into 27 9 times. And we'll leave this in exact form. So 4 times 9 is 36. So that would give me 36 pi t cubed. In other words, v of r of t is equal to 36 pi t cubed. Now, why is this such a nice equation? Well, think about what this allows you to compute. If we know the time that has elapsed, we can just plug in our time value, the number of seconds that we've been blowing up this balloon, and we'll immediately get out the volume, which is the amount of air in that balloon at any given time. So we don't have to take our number of seconds and first find the radius of the balloon, and then once I know the radius, find the volume. Instead of a 2-step process, it's a 1-step process, which is what you're going to see in part D when it asks us to evaluate V of R of 2. Again, rewrite that, V of R of 2. So since we've already created our volume function, volume as a function of time, we can use that. 36 pi t cubed. And you can see here, this 2 here is saying that that's a time of 2 seconds. So we're going to input 2 for time. 2 cubed is 8. So that would be 36 pi times 8. And again, we'll leave this in exact form. 36 times 8 is 288. So we have a volume of 288 pi. Now, units are important. And because we said earlier that the radius up here was measured in inches, volume then would be measured in cubic inches. So we can write inches cubed, or you could write out the words cubic inches. So now let's interpret this final answer. And this is basically telling us that after 2 seconds, the volume of the balloon, and it really is the approximate volume, since we said the balloon wouldn't be an exact sphere. After 2 seconds, the volume of the balloon is 288 pi cubic inches. And that's what we call function composition, where we're taking one function, substituting it into another, and the result is this nice function that allows us basically to skip some steps and gives us a direct volume for any given time.